Hi guys, good morning. I wanted to provide you with a mini lesson today about the seasons and kind of give you that link between our ability to connect atmosphere to our weather and climate, to climate changing, to seasons, and really the entire lesson for today is regarding our plants because visually I can see them change. Visually, I can see the weather change, but I can't really see the gases or the chlorophyll specific. So I want to share with you how this all connects. And I pulled up this animation to share with you. And I want to go over a couple things from the grassroots here. If we take this line right here, which I'm not quite sure if you can quite see it, this is the northern hemisphere, right? This is the southern hemisphere. When the sun in December is going to create sunshine or daytime on the earth, it is directly hitting the equator here. So it's true for me to say the equator is receiving the most amount of direct sunlight. It is also a true statement for me to say that the southern hemisphere is also receiving the most amount of direct sunlight if I compare it to up here. Because up here we're experiencing winter. We're tilted away. As our Earth does an orbital rotation, orbital revolution, the rotation is the day and night. The revolution is around the sun for the year. So when we're in December, we are experiencing winter. We are not getting a whole lot of direct sunshine. If I move over here to June, and I start over and the earth moves, notice the axis point does not change. The axis is a fixed position. It is a fixed position of 23.5 degree tilt. So if I am looking at this, I now see that the northern hemisphere is pointed towards the sun, therefore receiving the most direct sunlight. And if you take a look, if I move myself, if you take a look over here, you see, boy, we have a lot of really great sunshine. If I go back, let's just move to September. Watch the sun. It is no longer direct over top sunshine. It's becoming indirect. If I go to the next, it would be even less direct. Watch December solstice. So we're talking about solstice and equinox. It's the longest and the shortest day of the year. So when we look at a solstice, it's going to be, day, the type of day. If an equinox, it's equal day and night. We'll talk about that later though. So if I'm December, check it out. It's indirect sunshine. So let's replace this person with a plant. If that is a plant, and let's say it's a tree with beautiful green leaves, and I'm going to move back to June. If that's a beautiful tree with beautiful green leaves, look at all the sunshine that tree is going to be given. Again, let's pretend this person is a plant. And if you take a look at this picture over here, green, beautiful. So it is receiving direct sunlight. So when we have green trees in the summer, beginning maybe in March, April, May, June, that is going to be our direct sunshine time. As we move out of June, July, August, September, we start to have that more indirect sunshine and the leaves start to change. So the fall or the autumn seasons change. So we realize that the one thing that has changed was the direct and indirect sunlight. So when that happens, get down, Remy, my dog. When that happens, you are going to see that plant take all that chlorophyll and move it into the center of the plant. So maybe the stem, maybe it is down close to the roots. If it's a tree, into the bark, into the tree, into the actual branches. And when it does that, those leaves start to change color. They start to change color because the green pigment is taken in because that's the food, that's the chlorophyll, and what's left behind is the color of the leaf. It might be a red color of the leaf. It might be a yellow. You will look at some of the trees outside. They will be consistently that color in the fall. So that is because of indirect and direct sunlight. So again, if I move into December, because I live and you live in the northern hemisphere, we're experiencing what's called indirect sunlight. As we move to March, it becomes more direct, very similar to September, but it's moving up to direct sunshine. And then over here in June, our trees become greener and greener and luscious because that chlorophyll is being activated by sunshine. In plants, there's a chemical reaction that occurs in photosynthesis to start making and storing food. That chlorophyll is really important within that. So when you're doing your assignment today, and we're talking about how indirect and direct sunlight kind of make this happen, I want you to think about the fact that when we're in summer, that sunshine is, look at over here, right over that person, if not pretty close to. And when we're in the winter, it is not over that person at all. So therefore, that plant doesn't get as much sunshine to charge, essentially, its chlorophyll. So I'm going to pop over to this image over here and kind of share with you. If you take a look, that's not the one that I wanted. That's the same one. If you take a look over here, we've got the days for us in the winter solstice. It's going to be our shortest day of the year because we are not receiving a lot of sunshine. This is night. This is day. The earth is moving. That gives us our day and night. And then it also will orbit or revolve, and that will give us our year. Over here in June, that's going to be our longest day of the year for us. And that is because look at all the sunshine we receive. I mean, Alaska, that's when Alaska pretty much sees sunshine all day long. Here's where it receives really evening all day long. March and September are equal amounts of sunshine. So equinox is equal. So they receive equal amounts of sunshine in their day and equal amounts of day-night. So the nighttime, it's equal, 12 and 12. So I wanted to go ahead and give you that information. We'll go over this a little bit more, but I do want you to really take a look at that axis point and the fact that that axis point is definitely at a fixed position. It is not teeter-tottering back and forth, and that is essential to how we see our seasons. So I hope that that helps you a little bit. I really thought that this was a good tie-in with the fact that we have such beautiful season change right now, and we can go outside and we can look at the leaves changing. And remember that those leaves used to be green, and that pigment in green has been taken into the plant to store for the winter. And what's left behind is the actual color of the leaf, whether it's red or green. And then the leaves will die out because they're not receiving that chlorophyll. So the plant takes in all that chlorophyll, holds it close for the winter, kind of like it hibernates, and then everything that does not receive the chlorophyll will fall to the ground because it's no longer needed. And when the sunshine charges up again, coming into this March, April, May, June, right here, then all of a sudden that chlorophyll starts to activate, get moving, and move out to create new growth of the trees. All right, so I'm available at 12:30, so if you need me, let me know. Have a great day.